This Western Digital SSD that came in for data recovery to my lab, I thought initially that the problem was failure of the board. So just so it happened, I had identical donor, and I figured if I can't fix it, I'm going to swap it. I'm going to just swap the chip over. So the big problem with this SSD was that when you plugged it into PC3000, it wasn't showing up at all. The bottom registers were kind of grayed out. We can see here in PC3000 when I hit power, you can see the bottom status registers, they're kind of grayed out. So that usually indicates a problem with the board, but not always. And the reason I didn't think it was the board is because when I put tweezers into the appropriate holes on the board and power on the drive on PC3000, then we can see the drive becomes ready. Now you can't access the data when it's in this mode, unfortunately. And if you saw any of my other videos, you would have known that we use this mode to access the firmware of the drive, and then we can rebuild the translator or do any other firmware work. And then we can obviously fix the drive, but this drive is not supported. This particular controller was not listed in PC3000 as being supported. So really, I didn't have any other options but to try to swap it. We can see here it's in safe mode, but there's nothing I can do. There's absolutely nothing I can do here. And I had identical donor here in my lab, so I figured, why don't we try swapping? It sometimes helps, and the fact that the drive registers were showing kind of grayed out, I thought maybe we have a chance. So I grabbed the donor and got ready and started swapping it. Now these two donors were not completely identical. There were some small little differences between the two, but from my experience, usually that doesn't matter. The controller matched, the NAND was the same. Everything else seemed about the same. Now, when you're working on SSDs, you don't have to swap the controller. You just have to swap the NAND because that's all it's needed. So we're going to put it in a holder here, and we're going to start heating it and moving it. So we got our donor in here, and we're going to remove the chip. We're just going to flick it off the board. It really nothing to it. We just want to make sure we don't mess with the other components on the board, because then we have to fix that and it's a pain in the ass. And then after that, I had the donor prepped, and now I'm going to grab the patient SSD and I'm going to start removing the chip. This is the main memory chip. Well, it's the only one on the board anyway. So of course, for that portion of the job, I'm going to using a bit less heat, because I don't want to damage this chip further. It's already suffering some kind of issue, so we don't want to make these things worse. So we're going to heat it up slowly, and then we're going to lift it. Of course, I could have used infrared station like I usually do, but then a lot of times I use heat gun because I have I can see the chip getting ready. I can flick it off. I mean, it doesn't really matter. Either one works. So in this particular job, I decided to use the heat gun. So here's the chip removed. And now we're gonna have to clean it and reball it, and then we can slap it onto the donor, and then we can see if it works. And because I never fixed my microscope camera, this is the best angle I can give you. So I'm just cleaning the chip here with some wick and soldering iron. We gotta get all the old solder off because we don't want any of it there. We're gonna need nice clean flat surface, then some bit of alcohol just so it's nice and clean. Now we're gonna put it in the stencil. Here's my stencil that I still use to this day. We use some Captain tape on the bottom so it sticks nicely, and of course we have to align it so all the holes are over the pads, and then put some paste on it and start heating it so we can create some nice balls on the chip, so the chip will attach nicely to the donor. And after putting all this work into this particular case, unfortunately the swap didn't work. I even tried taking the chip off and putting the donor chip back on, and that worked. So I rebuilt the chip again, put it back on, and it didn't work. So that pretty much confirmed that the NAND was bad. So this case ended here. Now I want to talk about another case that I also had just recently. It was an ADATA SSD. This one had 4 chips, and this one I swapped. Let me show you what happened. So then I also had this SSD come in for data recovery. This one had a short on the board itself. So the shorted line, I actually marked all the capacitors that were shorted. So there was few here, few there. So I was trying to find the short, and I was removing one capacitor at a time and then putting it back on. And then I thought, well, why don't I just inject voltage? So I tried injecting the voltage, and what happened is the wire got hot instead of the actual component, because usually when you inject voltage, a lot of times you can get the component heat up. So then you can kind of figure out what the problem is, but that wasn't it. So this one also exhibited the same problems where the bottom registers were grayed out, and I couldn't even get this drive into safe mode. So figured the only way was to remove the NANDs and put them on the donor. The customer provided me with identical donor. So I swapped the chips. Now before I swapped them, one of the chips was getting hot right here, so I thought maybe one of the NANDs is bad, but I was wrong. It was actually the board that was bad. So I swapped everything over, I plugged it in, and then a lot of times when you swap chips, the drive needs some time to kind of reconfigure itself to work. So in this case, it took a bit longer. So it actually took a bunch of hours before the drive became ready. Although I've heard from people that sometimes it can take up to a day. So it hasn't happened to me. Usually it's a couple minutes to 10, 15, 20 minutes and the drive will become ready. But this one took a bit longer. So let's plug it into PC3000. I'm gonna show you what happens when you after swap to one of these drives. So we can see the drive is powered on. Actually, it became ready right away, which is kind of interesting. So I guess it just needed time before, because now I just powered it on and the drive became ready. And you can see the drive will be detected. Of course, this one is not supported, but if you go into Universal Utilities, we can see we got model, ADATA, SP600, we got the capacity and everything. And then of course, we can do sector edit, and then we can view that there's data. Here's data right there. So yeah, so this swap was successful, but sometimes the swap is not successful. But it's a good candidate for swap. Swap only works on drives that have board failure, not necessarily NAND failure, or there's something else wrong with the drive, like actually physical damage or something. Only then I've been successfully doing a swap on the SSD. Maybe in some rare cases you might have an SSD that has some NAND problem and something else along with it, and then you swap the NAND, it will work. But usually when I do swaps, I only do it on drives that have physical failure on the board, or there are shorts or things like that. But anyways, yeah, that's it. If you got this far in the video, welcome back. I haven't made a video since June last year, so I figured why not make a video this year, since it's a new year, 2024, might as well. Anyway, hope you see you next video, hopefully sooner rather than later.